All right, then I'm going to go ahead and give Eric the rest of the time. We got TxDOT standard drainage structures is going to be our topic today with Eric Lazenby, and I'll let you take it away.
All right, thank you, Matt. Go ahead and share my screen here. All right, well, good afternoon, everybody. My name is Eric Lisenby. I'm a section head in water resources up in our Tyler, Texas office. And today, going to be talking about the TxDOT standard drainage structures. This really is not a very flashy topic for a designer's roundup, but looking back on it, I think it was Matt Kroner's idea originally. So I'll just pass the buck on to him. Anyways, hopefully there's something y'all can glean out of this and some of the lessons I've learned. We're just going to do kind of a high level overview of all the different, or at least a lot of the different drainage structures that Texas has in their standards, and some of the things to look out for to avoid getting RFIs in construction, especially. So we'll just get started. So we'll start off by talking about the different standards for storm drain, the inlets, the manholes, junction boxes. We'll get into a little bit of when to use safety end treatments versus when to use inlets. We do a lot of highway design, so that's sometimes an issue. And then we'll touch on just the cross culvert drainage structures that TxDOT has and the standards there. So for the first structure in the TxDOT standards is their manhole standards, the PRM or precast round manhole. Some of the things you need to know about this when you're laying out storm drain design, TxDOT really does not want manhole access in their pavement. So a lot of times if we use the manholes to connect different pipes segments together. But if we're doing it under pavement, we'll probably not use these structures. If you're using it outside of pavement, it's okay to use a manhole. But if we're doing it under pavement, we'll use something else that we'll get into a little bit later. They also come in different sizes, so it depends on what size pipes you're connecting. You need to watch what size manhole you quantify and call out for. It also depends on the angles of them. There are there's different manufacturers that provide calculators that if you have different pipes coming in at different angles, it may require a different manhole base. So make sure you're considering that when you're laying out designing your manholes for your storm design. So the other option TxDOT has is their precast junction boxes. This is their PJB standard. Typically, this is used in a case where you don't need access. So we'll use it like this example on the right, where we can stick it underneath the pavement instead of a manhole and connect the pipes together. So again, TxDOT doesn't want the manhole lids on their pavement because they can pop off during major events. And so we would rather use one of these if it's under pavement. The other place that precast junction boxes are used is with their POD or precast overpass drain inlet. It connects, we'll get into the next slide. Most of the other inlet structures have a different base, but the POD has a junction box as its base and then an 18-inch riser pipe going down to it. So for the various inlets that are available, and all TxDOT's drainage standards are on the Bridge Standards website. I'll give a link to that later in the presentation. These are basically a lid, and they all fit onto the same base, which is the PB standard. We'll show on the next slide. They all just fit on top of that PB, and they're paid for by the inlet, which includes the price of the base. So this is the TxDOT PB precast base standard. So that goes, you include this almost always in your plans because it's with every different type of inlet, almost uses the same base. And you need to call out the inlet and size your structure so that it fits the pipes that are coming in. And as well, you need to make sure you have sufficient cover on it. So what this picture on the right shows is basically the standards for the TxDOT precast inlets. You know, they'll have a base, and then they'll have various risers that the manufacturer will put in and the contractor will install to meet the elevation that you're calling out on the plans. And then the very top part is the specific inlet that you're using at that location. So on the bridge standards page, there's also a guide for this TxDOT standard precast drainage inlets and manholes program that they have. And in that guide, there is this table, and it gives the height of assemblies for each different inlet type, as well as the minimum cover requirements. And I like to think of this as your stay out of jail card. You need to be, when you're laying out storm drain design, you need to have a calculator in hand and be looking very closely at these requirements for minimum cover and what the inlets require, and make sure your pipes are below that. I recommend, wherever practical and possible, not just stretching it too close to this, going a foot or two deeper when you can, so that you don't get drawings returned to you during construction because they don't quite meet specifications that can be built. So to kind of illustrate what this is showing, the height of assembly, that is the lid itself. So that 21 inches, this is for a PCO inlet. And this is the standard for the inlet. That's referring to this 1 foot 9 inches. And this whole thing is going to sit on that precast base. And so it needs that height, and then it's going to need a little more for your minimum cover, another 8 inches. And then that minimum cover needs to be at least above your outside top of pipe. So you have to factor in the thickness of whatever pipe you have tying into this structure. So again, stay out of jail. And for those of you who haven't been to jail like myself, this is what it looks like. It comes in the form of a shop drawing submittal from the manufacturer, and it looks a lot like the standards for whatever inlet you're placing, but it's going to have the specific name of your inlet that you've given it on the plans, as well as the specific top elevation and pipe elevation that you've called out. And where it's problematic is when they show your pipe going through the lid of the structure. And that means you can't just hit approve on the shop drawing and go on with your life. You have to get back to the design board, even though you're in construction. So recommend you pay very close attention to this as you're designing and laying out your storm, and stay out of jail there. This is the first type of inlet for curb and gutter systems. And this is the precast PCO or precast curb outside. It keeps the box of the structure where the pipes tie in behind the curb. This is the inlet we would recommend in most cases where we are doing curb and gutter systems, storm drain systems. It keeps the inlet itself behind the roadway, which I think is preferable to long-term maintenance and subsidence and things like that that can happen over decades if you have the structure underneath it. However, the PCU is not that much different, and it is useful, especially in cases where you have some kind of physical constraint behind the inlet that you're trying to get a little more clearance from. This is an example where we've placed just a standard PCO inlet and we have a utility running behind it. And so if we use TxDOT's other option for a curb inlet, here it is again. You can see on this next slide how much it sucks the back of that structure under the roadway. So it is a very handy design tool to get out of those tight spots, those type of situations. This is the precast area zone drains. You've seen these around, I'm sure, and they're a giant box with orifice intakes on all four sides. They stick up a foot out of the ground. On the drainage side, we love them. They take in a lot of water. You get a little bit ahead on these, and they can really just gulping the water. So we use them wherever you can kind of shed water outside the roadway. I do not use them where there's no sort of curb and gutter or some kind of protection, like on a ramp or something where you could just drive off into the ditch. I'm not comfortable with using them. I don't know that's strictly prohibited, but I don't want them to be a hazard for vehicles. But as far as other situations where they're tucked away behind a curb or rail, I think they're great, and we like them a lot. There are some districts, I know Corpus says they have issues with, I think their maintenance people hitting them on lawnmowers, but I don't know that that's a legit excuse, because I think they're pretty, if they can't see these, I think there's a lot of other things they could hit as well. So this is some examples of applications we've used. This is on the 390 project. We have just some open medians in an intersection, and instead of doing multiple curb inlets, we've kind of opened up the curb with curb cuts and did a little special grading area, let the water dance a little, and then take it in a PAZD inlet. So, and here's another option that, or another example for the Zarzamora Street. Ciro developed this, and we utilize, we had some utilities, so we didn't want to place a curb inlet here on Zarzamora Street. We used San Antonio's sidewalk bridge to let the water under the sidewalk that we're putting there. Did a little special grading and put a PAZD inlet to capture the water there. So it works great in those type of situations where you can keep it behind a curb. Precast slab lid, or PSL inlets. That's another standard TxDOT has. It has different options for the lid to where it doesn't even have to be an inlet. It could be more of a junction box, but usually when I'm calling out this PSL, I've used it as more of a grate inlet, because you can put the grate PSL FG is the style I use most often. It also has an option for SFG if you're using it on roadway pavements, like on a shoulder, where it slopes somewhat with the roadway. And, here's a kind of common example where you're in a narrow gore area and you place one of these. This isn't our project, but you place a PSL FG as a grade inlet to capture some of the runoff there. And this is one of my projects. This is 390, a similar example. We have a gore, the ditch is getting really shallow, and we'll just place one or multiple of these to capture the water and then take it across the roadway. This precast overpass drain inlet, the POD that TxDOT has, I'm not 100% sure what their intended purpose for them is, or what their main reason for making this one is. I think I know what it is, and I have used them on just some examples I'll show you. But I think they use it because, as you're going, you have an overpass, and maybe you have a ditch in the middle, and it can get very deep. So it wouldn't be very cost effective to use just a super deep structure with a lot of risers. So they've given this option to have just a top and then use 18-inch RCP as a cheaper riser to get deeper in the structure. But I've used these because, in my opinion, they're better than their retaining wall inlets, because you can size them to use a 3x5. However, you have to supply some of your own modifications to the detail. This is on the I-20 Lindale project. We called out a POD inlet, and we used those and supplied additional details. Instead of dropping into a junction box, we have a riser with the elbow bend that we call out, and then let the water come out the retaining wall face into a splash pad in our roadside ditch. So finally, there's some precast medium barrier drain inlets. I haven't worked on a lot of interstate projects. I've only called these out a few times, but this is for primarily like where you have the median barrier, and usually that's the high point of the roadway, but you may be in a super elevation section or something where it's not. These are another option. Instead of putting the grates, you can use this, which has sort of an inlet opening, probably less susceptible to clogging than a grate. And they're also pretty inconspicuous, as we'll see in this next picture. So this is one. Fun fact, none of the ones I've called out have been constructed yet. So I was looking for a picture and I had to just use my brain and think, where could these be? At first I tried Houston, and then I realized, they're kind of high and mighty and have their own details, and they don't use all of TxDOT's standards. They use some of their own as well. Couldn't find any there, but found this on I-35 in Waco, and just scanning for a super elevated section on an interstate. And you can see, you might not know it's there unless you really look hard, but there is like an inlet opening there that's going to let the water in, and they're probably running storm drain right along this barrier. So a little design talk for using, when do we use SETs, when do we use inlets? I think SETs are preferable to inlets wherever we can on roadside drainage. So the key to these is like, if we're deep enough to stay on. Yeah. So if we're deep enough to stay under the pavement section of the roadway and get to the outfall ditch that we're going to, then we can go with SETs. So I'm calling this, as your ditch gets deeper relative to the roadway, I'm calling this the SET zone. But some cases are widening, or introduction of a new frontage road or something requires us to shallow up the ditch. And in that case, we might not be able to fit the SET underneath, or fit an SET in and take our pipe under the roadway. And so in that case, we need to switch to using inlets, one or multiple inlets to capture the water. And in that, as we discussed earlier, there's cover requirements. So this red line is representing, you have some minimum cover you have to achieve with the inlet before you can stick your pipe under the roadway. And so as the ditch goes up relative to the roadway, you're in this inlet zone where an inlet's going to work. And the thing to be aware of when you're designing the ditches or laying them out is, because there's a zone where if you're deep enough, you can use an SET. And then if you're shallow enough, you can use an inlet. There's also a no-go zone in most cases. I can't set specific numbers on these because it depends on your pavement section and the size of pipe you're dealing with. But there's a no-go where you're too shallow for SETs, but you're not shallow enough for inlets. So when you're designing, make sure your low points of these ditches are at a place where you can use either or. Otherwise, a lot of times we'll just kind of go through and make sure it's positive drainage, but we won't be thinking about the actual structures that are going to take the water across. And then we'll have to go back and adjust our ditch profiles to where we can get structures to actually work. So it's a good thing to be aware of, that we have to make one or the other work. In most cases, if you're deep enough, both will work, but that's kind of rare in my book where you have that much depth to play with. And as you're doing this, sometimes you gotta just think outside of the box for maybe not the first solution that might always come to your mind. This is something I was working with Luis Bautista on a few weeks ago, and we had a raised ramp and then a frontage road. And so it was hard to really get a deep ditch in here. We were having a hard time making it work and be able to get a pipe across. As we looked at it a little more, the solution jumped out that, hey, we're only dealing with 1 or 2 lanes on this ramp and then a frontage road. It's no problem to just let that water sheet flow across as long as we're not concentrating it. Look for solutions like that where you're able to make the drainage work. So to switch gears a little bit and talk about some of the culvert in treatments, I say box culvert, but mostly applies for box or round pipe culvert, what we're talking about here, except for your box culverts, just be aware that we do have, as the drainage designers all know, we have a BCS sheet that we fill out as part of the end treatments for all the box culverts. And what I'm recommending here is do that as you're designing them, looking carefully at the standards and then filling out that. Sometimes you read the standards, you think you have an end treatment that's going to work, but it has certain limitations on head wall height or length, and it actually doesn't work. But if you're filling out the BCS sheet, those things will get flagged and you'll realize, oh, I need to switch the structure here. Also, always draw it to scale. That helps other teams out and helps us get the right quantities on the riprap we're placing around the end treatment. So always start out drawing it to scale or use the ORD cells and check that they're drawn to scale when, do that BCS sheet, and it gives a lot of the dimensions, and be checking that stuff as you go. I also recommend using the safety in treatment options whenever possible. They are a little more restrictive, so it might not allow you on some cases, in which case you'll just have to use, and I'll show you in a second, but there's, with a lot of the box culvert in treatment details, like your flared wing FW0, there's also an SET option that has these bars and stuff when it gets big enough. So I recommend just going with those. If your culvert is bridge class, meaning it's 20 feet or more measured along the center line of the roadway from inside to inside, then you have to protect it, whether or not it's in the clear zone. You have to put some kind of protection. And I think, if I'm not mistaken, the SET qualifies as that, so it would keep you from having to use barrier. I wasn't, although my memory fails me, and I was like, did they make us use barrier even when we use SET on one of these? But I don't, from what I could find, I don't think you have to. If you're using an SET, that is protection. So I recommend just using those whenever you can. I think it's safer and just a better option. But here's some of the different configurations for end treatments. So you have your flared wings, which I think would also be our first choice whenever space allows. It allow the wings just conform with your slope. They come out at a standard 45 degrees. So if you just have a straight culvert perpendicular to the roadway, this would be the first option. If it's skewed, we'll get into that a little bit more, but the skew is talking about the skew is talking about the skew of the culvert itself to the head wall. And that, so you'd have a stream going out this way, then you'll want to keep the head wall parallel-ish to the roadway or parallel to the roadway. And so then you end up using one of these skewed head walls, and it allows the water to just go with the direction the creek's going there. And then lastly, when we're constrained on right-of-way, this is another option. These parallel wings they're almost like a retaining wall, so they can fit with limited space. But I would say that is only, if we have our choice, we'll use the flared winged options on culverts. And they have configurations, they have standards for these for both. Well, it's the same standard, but for skewed and non-skewed options here. So on culvert skew, I just want to point out that is, again, the skew of your culvert with the head wall, not necessarily with the roadway, although it usually is somewhat coincides with that, but it doesn't have to be. But it does, per the standards, you only have certain angles that can work for this skew. And so the skew with your head wall to your culvert needs to be one of those angles, or you're going to have to modify the standard. And so it's usually 15, 30, or 45. So that needs to be an exact angle, not necessarily with the roadway again, but with the head wall and the culvert needs to be exact there. So just to point this out, I mean, this case, you have a culvert skewed like this, and a channel going this way, and say, we're not going to do this very often. Usually we do want the head wall to be parallel to the roadway, but if we can take it far enough out so it's not an obstruction, this case would not be a skewed head wall because it's perpendicular to the culvert. And so it would be askew when the head wall itself is angled with the culvert. So here's some helpful links to the documents. Again, all the drainage standards for these structures are on the bridge standards webpage that TxDOT has. This is the guide that has the standard inlet and manhole program guide that shows your table with your minimum cover and assembly heights. And then TxDOT did some kind of webinar a while back and just kind of assembled some facts about their standard inlets and manholes in this link here. And that's really all I have if there's no questions.
All right, yeah, we had, Kenneth did chime in at least to cover, mention that the SET doesn't need a barrier, but the side slope might, but otherwise there really wasn't any chat or questions, but it doesn't mean anybody else doesn't have anything to pop in with. Or perhaps nobody does. Anybody want to speak up? All right, well, I guess we've got a short one then today, if that's all we needed. Appreciate Eric giving us the presentation. And obviously, if there's questions afterwards, you can always add them in the chat, but otherwise we'll catch y'all in a month.
All righty. Thank y'all.
Good job, Eric.